hi. I'm super excited to be here. My name is Yaacov Rydzinski. I'm an independent contributor to open source GraphQL projects. I got involved within open source actually through the GraphQL tools repository in the JavaScript ecosystem as the repository was making its way over from ownership under Apollo and now with its current ownership under the Guild. During that limbo time, I got involved with the project and started working on fixing bugs. I had forked the repository and then was really excited when the Guild took over and took in a lot of my changes. So my initial development was really around schema stitching, and the repository still uses a lot of my code, which I'm super excited about. But of course, it's now supported by the Guild. Arda is managing the GraphQL tools repository, and of course, building even additional layers on top of it with GraphQL Mesh and a lot of other different functionality. So that's how I got started, and then I just continued to just fall in love with GraphQL. And it's really a special community. I am not a professional programmer. I'm an open source developer who found a wonderful, warm, and welcoming group of people. First, through Uri in the Guild, who reached out to me and said, "What are you doing?" And I said, "Well, I don't know." But he said, "Well, maybe you're doing something great, so keep on trying." So, I started attending working group meetings, and I just want to give a huge thank you to the entire GraphQL community for being so warm and so welcoming of someone of my, I guess, non-traditional background, so to speak. Having said that, I've been really happy to contribute not only within the GraphQL tools repository, but also within the reference implementation. And I hope some of my comments in those working group meetings have also been broadly helpful or interesting to the professional programmers among you. And I'm really excited about incremental delivery. I got involved within the project of incremental delivery because I was trying to figure out how schema stitching or a GraphQL gateway would work in the context of incremental delivery. And then I got sidetracked, as I guess you can guess that I often do, by how incremental delivery is working itself. So a few public service announcements. One, a huge thank you to Ivan in particular, who manages the main maintainer of the Graphql-js reference implementation, who I pointed out to me he couldn't be here with us, but I mentioned to him that I'm going to give him a huge shout out. Another huge thank you again to Uri and Dotan of the Guild for sponsoring my open source work. Because of their financial support, I was able to convince my wife to actually let me spend so much time on this project. And of course, if we're going to be talking about incremental delivery, we really can't start talking about it without giving a huge shout out and a huge thank you to Rob Richard, who is the champion of this feature and has really been pushing so many of the architectural decisions forward. It really done a majestic job, I think, of synthesizing all the different opinions and everyone's input within the sub-working group. And I want to particularly thank again Benjie and Rob for working on the new response format, which my implementation is based on. So what's so exciting? Well, just about 2 weeks ago, we merged into the and then released a new alpha in the reference implementation that performs incremental delivery, but also performs deduplication. So I'm going to see if I can get this to move forward. Otherwise, I'll just do it from here. I'm going to be talking about the basic motivating case of incremental delivery, the use case, a little bit of how we got here, and I want to talk about how we can do incremental delivery outside of the GraphQL spec, because I think it's important to realize that when we enter the GraphQL spec and introduce the new deferred keyword, the new deferred directive, why our opportunities change. And I think it's important to look at how we might implement it outside the spec, and that'll give us some insight into deduplication, the second part of what I'm going to be speaking about. A little bit in theory and in practice, I'm going to be going over the fairly straightforward algorithm for how we perform deduplication within the newly released alpha, and then I'm going to be talking about some challenges and some opportunities. So thanks everyone for tuning in, and here we go. So we want to incrementally deliver data using GraphQL. And the reason why is because, for example, we may be powering a web page by declaratively describing all the data that's required to render that view within the web page for the user. And we want to progressively render that so that the user can interact with that web page as soon as possible. And it's very likely that if the client developer gives us some hints as to what we want to render first, which portions of the data are necessary for that first meaningful interaction, and which those are the non-deferrable portions. And as well as a separate portion that is deferrable, it's very possible that we can achieve a shorter time to initial meaningful interaction by that user. And that'll give the overall experience for the user will be much more gratifying. Everything will appear to load faster if we can actually start loading portions of it faster. So how can we do this outside of the GraphQL specification? Well, I showed you already that there are two different sections, let's say, of data, two different sets of components on our of our view that have different portions of data. So why don't we just send two different requests? We could have one request, let's say it's information about the user, and a second request, information about that user's friends that we want to send later. So then we can get two separate responses, and we can just render those different portions of the UI as those responses go. So what are the advantages to this basic kind of approach? Well, it's super simple to reason about. It doesn't add any new GraphQL functionality, and it's pretty straightforward to implement. So what's the problem? Well, the problem is the client becomes chatty. It's issuing multiple requests for a given page. And those requests then have to be serialized by the client, deserialized on the server, parsed, validated, and then executed. And it's also true that the request delivery order is unspecified. Both of those requests are going to start executing as soon as the server receives them. And the server has no knowledge of which one is actually more important. And finally, I mentioned specifically there's repetitive execution along the path to the deferred fragment. So that's something that, all of these things are things that we want to fix. Well, we can add on an additional layer that will immediately fix some of these problems, and that's batching. Now, the normal way that I've seen within the JavaScript or TypeScript ecosystem of how to do batching is a data loader type of batching, in which we send multiple requests using, for example, let's say the batch execute or the batch delegate functions within the GraphQL tools library that power schema stitching. You have a data loader type approach in which you send multiple requests and you don't get anything back until all of them complete. And that would not help us at all in incremental delivery. But let's say we had a smart batching function in which we could send multiple requests and get a multi-part response back, and the server would send the results from the initial operation as soon as they're available. So that would actually help us for incremental delivery. And again, there isn't really any new concepts. What we're doing is we're just sending different operations. And we could even make the batching smarter so that the server knows to send, let's say, the first request earlier to represent the non-deferrable portions and to hold back on sending maybe a heavy payload about the friends until the client has received the information about the user. So still super simple. But what are the disadvantages? Well, we haven't gotten rid of many of the disadvantages. There's still repetitive execution along the path to that deferred fragment. The me, the user, all that is, again, serialized on the client, deserialized, parsed, validated, and which is not necessary. And finally, we could optimize this a little bit further. Let's say if we how can we shorten that second operation? Well, what we did over here is we added a pointer. We requested some additional data to deeper within the graph. And we requested the ID of the user, which we're going to need for the follow-up information. And then we added an argument with the deeper root field to that additional information that we're going to need. So now we've shortened the path to execution in that follow-up operation. And that helps us, right? And we can even do this automatically. We can even have a layer sitting in front of our GraphQL server that takes the same two requests that we used to see and automatically transpile them into what we see over here. And we can add in the solutions we talked about batching. We can throw in persisted operations as well, so that, again, we really have condensed and given a solution without changing the GraphQL specification at all. So, but what is the problems here? What are the disadvantages? Well, the main disadvantage is that additional pointer overhead complexity. And you have still repetitive execution of the final field in the path. The GraphQL server doesn't know, presumably, hopefully it has in its cache, but it still has to re-execute that user field, that last field, even in our shortened operation. And it only works if the schema provides that pointer and provides shorter root access. Now, if you're talking about a server like Relay, in which a lot of things can be identified by, let's say, a global ID, that might work better. But in a more insidious problem, you could argue, is that now we have a clear linkage between the two different operations. You can't start executing the second operation until you get the result back from the first operation, because there's no change within GraphQL, and so therefore those semantics of requesting that pointer and then using that pointer happen outside of GraphQL, and so you can't start that second operation until the entire result, all the information about the user is returned, not just the ID. So how can we, and so this is just a semantic showing those different waterfalls. We can't start the second operation until the first operation completes, and we're going to be calling that delayed execution, where if there's some overlap, that we would call that like early execution or concurrent, or what I like to call semi-concurrent execution. And that, you see, doesn't really change the time that first payload is delivered, but is going to lengthen the overall time for that second payload to deliver. So what would we like to do? Well, we would like to mark up, we would like to have some new syntax within GraphQL that lets us describe portions of our operation as things that we are okay deferring until later. Okay? In fact, the client is requesting that these things be deferred to optimize the progressive rendering of the UI. So advantages, well, simple to reason about, again, that deferred fragment really describes well what we're trying to do. No multiple client-side requests, no repeated execution of fields within the deferred field path. And I'm just going to say that again. Within the deferred field path, there is definitely no repeated execution of fields. There's no need for a pointer, no need for root field access, and delivery order preferences are clearly communicated by the whole semantic of how we're using defer. We can also specify defer on a fragment to make sure that fields are only sent when all of the fields of a fragment are useful. And it preserves the potential for maximal concurrency. The server can then decide when to execute those deferred fields. And if it wants to, it can execute them early. So what are the disadvantages? So big question mark, right? So let's take a step back. GraphQL, what does it allow us to do? It allows us to declaratively describe the requirements of a single component and also of multiple components. Well, in a single component, what we're talking about is collapsing the client-server waterfall, so that all of that happens on the server. The client doesn't even actually have to know how it happens. It just asks for what it wants, and it gets what it wants in the format that it wants in one simple request. For multiple components, what's very helpful is that no matter how many components require how many overlapping sets of fields and of subfields, each of the fields that the client sends to the server is only going to be executed once. There's not going to be any duplicate server-side work, and there's not going to be any amplification of the response size. So I'm throwing up I'm not sure if you all can read it, but just trust me that these fragments reference themselves, and there's going to be a lot of duplicate information that's requested. However, the response is going to look like this. Four different fields, each of them executed once and delivered once. What about if we throw on defer? So in our initial implementation in the Graphql-js repository, our initial implementation of defer, you would get a result that looks something like this. Now, this would be the first payload, and it would have within it the initial response, and it would also have a description of what deferred payloads are pending. And that's useful because, I'm not going to spend too much time on it, but that's useful because what if these fields that the client thinks are slow actually, for some reason, are super fast? Something changed on the back end. That's the simplest scenario in which I think it's useful to see why we need this pending field. And so it could be that the server wants to maintain the ability to actually just send everything, to eagerly execute and eagerly deliver all of those deferred payloads. And that's an advanced use case, but you wouldn't be able to tell exactly what's going on unless we have this description of pending. What about the follow-up response? Well, this is how our initial implementation sent the follow-up responses. Even though the name was sent originally, the name is sent again along with the email corresponding to that first fragment. And then the same for the next couple fragments, so that when the last fragment, name has now been sent 4 times. Email has been sent 3, et cetera, et cetera. So we have a lot of duplication. And there's something a little bit more insidious going on, I think, in that all of these fields are being delivered more than once, but they're also being re-executed on the server more than once. And that means the data can change on the server even in the middle of a GraphQL request. I mean, we have that when data is referenced at different portions of the tree, but here we have it even at the same portion of the tree, the data can change, as well as just all extra bandwidth. So GraphQL can now stream data, but if we take a look at how we changed the response, we took advantage of GraphQL semantics to introduce a directive that accomplished that, that batching of different requests that are then delivered separately. We solved a lot of our problems on the request side, but on the response side, the response is essentially the exact same response as if we hadn't changed GraphQL semantics at all. And the question is, can we do better? It seems like we should be able to do better. It seems like if there was a real GraphQL type incremental response, it would look different than incremental response that doesn't change GraphQL at all. And that's why, and that's why the incremental delivery working group pushed forward on this. Is there anything we can do to reduce the response size? So what are some different strategies? So some failed strategies. Failed and by me personally, threw in some strategies that were rejected. So what can we do? We can mark each path on delivery. We can mark those items as sent already, and we can just skip delivering anything, but allow duplicate execution. Well, that's actually pretty dangerous. And this is a comment posted by Kuwait from Meta, who one of the members of the TSC. And this is an example that Rob put forward for why it's actually dangerous. Let's say you have someone who comments something, a really nasty comment, really terrible. And so we have a UI that's going to render that most recent comment, a really terrible comment. And then I comment, and I have a really nice comment. Yaacov, your talk, I'm talking to myself, your talk is really going great. Everything's fantastic. That happens exactly in between the time that the that the initial result is requested and the deferred result over here is requested. If you have a situation in which we allow re-execution, but we deduplicate delivery, what you're going to end up with is the response on the right, that the most recent comment that's delivered within that incremental payload, I'm going to be specified as the author of that comment. Whereas the initial payload had the text of the comment being someone else entirely. And that's true even though the client developer tried to guard against this by including a request for the text of the comment within that deferred payload. But because of deduplication of delivery, but re-execution of the fields within the referred fragment, we have a really dangerous and confusing footgun for incremental payloads. So if you're going to deduplicate delivery, you really have to deduplicate execution. Okay? So what if we maintain, JavaScript has great weak max support. What if we just have a global execution cache? So not every language has support for weak maps, and that leads to a lot of questions as to how exactly you can maintain this cache, decide to evict data from this cache. Otherwise, we would have to maintain in memory the results of every resolved and completed field throughout the GraphQL response. So it seems like there should be a way within our analysis of an operation, a query, to decide how to do deduplication. And it turns out that there is. So this is the second section, deduplication in theory and practice. So we have to think about why fields are deduplicated. Now, our rules in incremental delivery, our ground truth rules, is that we always deliver the initial result first. And we always deliver the deferred result after the initial result. That's just how incremental delivery works. And so therefore, if you have an operation like this, where name is within the initial result, but is repeated later, it's always true that that initial result is going to be delivered before the deferred results. And so no matter how many times name appears later, it's never going to need to be included or re-executed within those deferred results. Now, there's a second situation where you could have duplication and a separate type, therefore, of deduplication, and that's sibling results. So let's take a look at not the name field, but the email field, let's say, which is referenced in these other fragments by being spread through that initial fragment. So if name and email are delivered first, resolved first, and are delivered along with the first deferred fragment, we don't want to include them. We don't want to include email within the second deferred fragments. But it's order dependent. We would want to include it the first time. So in this scenario, you can't know when exactly you would want to deduplicate from the beginning, when you would want to deduplicate email, but you know that you only want to send it once. Again, it should be executed once. Whichever fragment completes first should trigger delivery. Okay, so this is a lot of text, okay? But I want to just focus on, we have two types of duplication, and therefore two types of deduplication, and we can do both of these by organizing how we collect our fields and retaining data about the origin of those fields from the different fragments, and the target of those fields, the target meaning when we deliver them together with which fragment. So the big picture, starting at the first point, is that we preserve the target, the enclosing deferred fragment that we're trying to deliver that field with. We preserve that within the GraphQL execution process. We don't throw away that information. And then for each key, we determine the target set, the target set that is controlling. And we exclude the sources of deferred fragments and the incremental results, those targets. We exclude those from the set if they have a parent in the set also. And that's basically how we get rid of type 1 duplication. We make sure to never deliver a field if it has a parent in the target set as well. And then we group together all keys that have the same target set. We group those together. So we form a lot of different combinations. Email, for example, was going to show up in, was going to show up in the user, in all three of these deferred fragments, whereas role just in the second two and special field just in the last one. So each of these fields, in this particular example, gets inside a different group because it may need to be delivered in a different order. And then we just, as soon as we deliver one of those groups with that incremental result, we mark that as delivered and never deliver it again. So the full algorithm is put together as a spec PR. Now, there is a little, there is some issue in how to phrase this language within the specification. And whether, currently the latest question the working group was deciding was whether to specify it as taking into account the possibility of early execution, specify it as saying later deferred as that we never have early execution, but clients, servers would be allowed to do so. But putting that aside, the deduplication algorithm basically works in the same way. And so what do we have? We have all of these responses deduplicated using the approach that we have over here. And notice that what changes in our response is that in the incremental array, we're no longer sending a full result. We're just sending the progressive data. We no longer have incremental duplicated branching responses. We now have just progressive inclusion of data, and we now have just what's needed for the UI to progressively render. And in the completed field, it's going to describe which fragments have been completed. And I'll give you this different example to show you why the completed field is necessary. Here, special field and role were resolved in opposite order. And special field was resolved first, so that when role is resolved, two different fragments just like that with the same instance have now been completed. And so the units of incremental data have been decided are fixed from the beginning based on our algorithm. And when they complete a fragment, we notify the client as to which fragments that have been requested have been completed. Okay, so what are the advantages? Well, clients get exactly what they want and nothing more. And servers execute exactly what they need to execute, and they execute that only once. There's a potential for maximal concurrency. Servers can choose whether to execute these requested deferred fields early if they would want. A less clear advantage depends on your point of view and when you think fragment modularity and alias fragments might eventually get into the specification. But a less clear advantage is that if certain clients actually want that duplication, would like to see the whole response in a follow-up fragment, there is a different feature that might be a better solve. The fragment modularity proposal with alias fragments might say that we want, which might require a new response format, maybe not, but that might be a better way to specify that we actually want duplication. What are the disadvantages or challenges as I finish up in this last section? Well, there's no exact equivalence between the deduplicated and the duplicated format. So right now, if somebody, let's say, would prefer the duplicated format, you can't 100% reconstruct the duplicated format from the deduplicated one. And that's because we are incrementally including all these pieces of incremental data within the initial response. The client is going to have to do that on their own and maintain a cache for that for the portion of their request. And that, so that incremental response won't necessarily contain just the deferred fragment that those components are looking for. It may contain additional information. It won't contain anything wrong, but it may contain some extraneous information. And it's difficult, at least without knowledge of the original operation, to just reconstruct the response. With knowledge of the original operation, you could certainly, re-execute the query from your cache, but that's not necessarily a straightforward task either. What about the other way around? Can you go from the duplicated format to the deduplicated? And the answer is you can't, because because our duplicated format had re-execution of fields. So we talked before about how if you want to deduplicate, it's not safe to deduplicate just delivery and not execution. And so that you can't go exactly from the old format to the new format as well. Now, code gen, using the new format might be more complex. But what will help out is, again, we have very predictable, maybe numerous, but definitely predictable pieces of incremental data that might go within that array based on how the different fragments fit together. And this is what, the next one is that look-ahead tools must be developed. If we expose to resolvers the additional information about which fields have been deferred, the sources, and then the targets of those fields, resolvers need to know what to do with them and how to take advantage of them. And we have to develop the tooling to allow them to do so. And finally, this is the area that was originally got into incremental delivery. This is going to be particularly complex for GraphQL gateways that are going to be taking one operation, splitting it up, and sending it to different end servers. Those servers may or may not support defer completely, and if they do support defer, those bits of incremental data may be in different formats, probably will be in different formats based on how the overlap between the deferred fragment works for the sub-schema as opposed to how it works for the composite schema. So it's not 100% straightforward for how gateways are going to manage this new response. Although considering that gateways, even in the old format, had to manage sub-schemas that didn't support defer, it's not necessarily a new problem. Finally, is early execution safe? The version that we have within GraphQL-js now performs early execution. And the answer is that it's not always safe. It could be that we enter a situation in which the non-deferred fields could block, the deferrable fields could block our non-deferred fields. Just imagine you have a very deeply nested resolver that the client says it needs initially, and then you have a less deeply nested resolver that the client doesn't need. This very deeply nested field may have multiple levels of weighting of async functions that then the slow field might be called first. And if they require the same end resource, then it could lead to blocking. So we have some techniques, but we're still trying to figure out when it might be safe to enable early execution. I'm running low on time, but I'll just point out that we're trying to work on different approaches to data loader. Working on a Paraloader utility that might help with that. Maybe a query planning engine like GraphQL could help. And we're also considering simple resolver helpers that allow additional information to be exposed through the info argument that will tell you when the entire parent level has been completed, and can also be used to describe a schema as using potentially blocking resources that you can then use in your resolvers to say, when has this resource been completely exhausted? And that basically is just a challenge for any framework that uses early execution, not necessarily for deduplication, but it is important to highlight considering that we now have available a deduplicated semi-concurrent version of incremental delivery available in the reference implementation within the latest alpha. It's so ready to use that I think I can demonstrate over here it actually being used. And so I used GraphQL Yoga over here. You see the logo over here just because they have a graphical that I saw on their website supports incremental delivery. And you can see how the graphical, what it's doing over here is it's supplementing the initial response. First, the fast field comes back, and then the deferred slow field comes back. And this is using the latest alpha. It just needs a little bit of a shim, which I have over here as a plugin, this use engine plugin. That's just using the latest alpha and transforming the response into what GraphQL Yoga expects, which is this one single async generator, as opposed to the paired initial result and async generator we hear. So I'll publish that as a gist, but the basic thing is we have a call to action for all of you here today. You have work to do. Please use the latest GraphQL-js alpha. Please let us know what we're doing wrong, what we're doing right. And thank you so much for your attention. Any questions? Okay. Oh, yeah. Yeah. So the question was, under the hood, what exactly is happening? How are these different responses being sent? So there is we actually had some earlier talks today, I think, about the transfer protocols. What we're using over here, and to be honest, I'm not super familiar with all the specifics of it, but what you can see over here is that we're indeed sending a multi-part request, and we're sending 2 different payloads. The first indicates that there's going to be a follow-up payload. It has that has-next value. And the second one contains the incremental piece of data, and then that deferred fragment was resolved. Now notice that the algorithm that Graphical is using over here is patching the initial response with the incremental data. And I didn't have to change the algorithm at all, even though we're using the latest alpha, because all we're doing now is patching that incremental object with deduplicated data. So we're patching it less, but the algorithm is going to work in the exact same way. Not only that, but one of the advantages for the new format is we only execute once and we only deliver once. And so every time we insert something into the initial object, in the old version, you may have had to do a deep merge. But in the new version, because we're delivering each key only once, you only have to do a simple insert. And that's what, I'm not sure if under the hood they're actually doing a deep merge or not, but you no longer need to in this new version with the new alpha. That's a great question that requires a more detailed response, but I hope that gives you some more to work on. Yeah?
So with the federated graph, model correct here, if the subgraph doesn't support deferred, is the deferring and all that, is that going on the gateway?
So the question was, if a federated, I guess a subgraph doesn't support defer, what is the gateway to do? And the answer is the gateway can do some tricks, can try to do some tricks, but it can't, if it can't just proxy the initial request. Because if you think of a simple proxy with just one subgraph and the supergraph is just sending everything there, if the subgraph doesn't support defer, that's going to delay the initial data load. And so you may be back to a situation in which you're utilizing some of the other techniques outside GraphQL that I talked about earlier in the talk to sort of mimic that defer functionality. And the subgraphs usually know, they're not quite like Relay where everything, or not everything, but many things have an ID, but subgraphs are often able to send different requests, maybe to optimize the operation. They could always fall back to sending a complete different request and requiring re-execution on the subgraph. But it is a little tricky. Okay. Thank you all very, very much for your attention, and I'd love to meet you all, as the rest of the day continues. Thank you so much.